In this video, we're learning how to complete the square. So you'll want to pay attention to the steps I have listed here in green. They basically tell us the procedure we'll use to solve these problems. So first step is to divide all the terms by the leading coefficient. So in example A, the leading coefficient is this value 2. If we divide all the terms by 2, it means we divide each of these by 2. Now 2 goes into 2 one time, leaving you r squared. So those cancel out. Then we have plus 3 halves r, then minus 9 halves is equal to, 2 goes into 0, 0 times. All right, from here, the next step is to move the constant to the other side. So we're going to take this and move it to the other side, making it positive, of course, as it goes over there. So we'll have r squared plus 3 halves r is equal to 9 halves. All right, from here we're going to do the complete the square step, essentially. We're going to square half of the b term. So I'm going to come over here and first identify the b term. The b term here is 3 halves. So I'll take 3 over 2 and I'll multiply it by a half, right? That's taking half of it, essentially. And then we will square the result. So if I do that, 3 times 1, of course, is 3, and 2 times 2 is 4, and then I need to square the result. Now when I square the result, I'll get 9 over 16, and it'll be positive. And now I'm going to add that result to both sides of the equation. So I'll put a plus 9 over 16 here, and a plus 9 over 16 on the other side. All right, from here, we're going to essentially factor. So we're going to factor and then simplify the constants on the other side of the equation. So if I want to factor this, I have to think about the ways that I would split this trinomial up into 2 different pieces. Well, certainly it would be r and r. Now here's the thing, we've created a perfect square trinomial. That's the point of doing the complete the square step. You've created a perfect square trinomial, so we know it's going to factor into something times itself. So if you look at the positive sign here on the right, it tells you it's going to be 2 of the positives there on the left, right? And you can actually get the answer for what the factoring is by going back to the step where you completed the square over here. So where you took half of the b term and you squared it, that 3/4 that we had right before we squared it, so it's that 3/4 that we need to add to both sides of the factoring. The reason why we do that is because if you check, you can certainly confirm that 3/4 times 3/4 will give you 9/16. We know that because we squared 3/4 to get 9/16. And then you can also confirm that 3/4 plus itself will give you the middle term. Remember, that'll be 3 plus 3, or 6 over 4, because we keep the denominator when adding fractions. And if you reduce that, you will in fact get 3 halves. So in other words, the factoring really doesn't have to be thought about because it's always going to be, in this position in the parenthesis, will always be the thing you had right before you squared it. Or in other words, it's just half of the b term. So what goes in here, remember, is just half of the b term. So the original b term you had, after you cleared the leading coefficient from the problem, then half of that b term is what you're going to place in these 2 positions inside your binomials. Okay, good. So we have the factoring now. Let's just clean up the other side of the equation. Both of these fractions can have a common denominator of 16. So how do we get 2 to become 16? We have to multiply by 8, right? That means we need to multiply the 9 by 8 as well. So both of them by 8. 8 times 9 is going to give you 72. And you'll have the plus sign from before. And this already had a denominator of 16, so we'll just have 9 there. So that's going to give us r plus 3/4 squared, right? Same binomial multiplied by itself, so we'll just say r plus 3/4 squared. And then we have 72 plus 9, which is going to give you 81 over 16. And then finally, we apply the square root property to solve, right? Or the square root method to solve. So what we mean by that is we're just going to take the square root of both sides of the equation. So square root of r plus 3/4 quantity squared will be equal to plus or minus the square root of 81 over 16. And when we take the square root of the left-hand side, the square disappears, and we end up with r plus 3/4. And that will be equal to plus or minus the square root of 81 over 16. What's nice about that is the square root of 81 is simply 9, and the square root of 16 is simply 4. So we end up with plus or minus 9/4. Then we just split this up into two equations and we solve. So r plus 3/4 is equal to 9/4, and r plus 3/4 is equal to negative 9/4. So if I subtract 3/4 from both sides, we end up getting just r on the left, and then of course 9/4 minus 3/4 is equal to 6/4, which can be reduced as 3/2. So r is equal to 3/2, and on the other side we'll have minus 3/4 to both sides, just like we did before. The 3/4 cancels out, and we end up with r is equal to, so if you have negative 9/4 and then you subtract a 3/4, you get negative 12/4, but of course 4 goes into 12 evenly 3 times, so you end up with negative 3 as your solution. And all that's left to do is to check your answer. All right, let's look at example B then. For example B, we're basically going to begin with step 2 because we already have a leading coefficient of 1, so we don't need to worry about that. The number in front of y squared is just 1, so we're good with the first step. All right, the second step is to move the constant to the other side, so we're going to rewrite the equation y squared plus 3/4 y is equal to 5/4. Then we take half of the b term and we square it, so let's just work that out over here. So we'll say 3/4 times 1/2, and then we're going to square that result. That's going to end up giving you 3/8, and then we will square that result to finally get 9/64. All right, let's add that to both sides of the equation. So we'll end up with y squared plus 3/4y plus 9/64 is equal to 5/4 plus 9/64. All right, from here we need to factor this perfect square trinomial, and we can just write it automatically as something squared because we know it has to become something squared. Okay, so how is it going to factor? Well, remember, it'll be y squared becomes y and y in the parentheses, and then remember this plus sign means we'll have 2 of whatever sign is on the left, so we're going to have y plus in the parenthesis. And then to fill in the last position, remember, it's whatever you had right before you squared in this step. So we're just going to write 3/8. And we know that factoring will be the correct factoring. Now for the other side of the equation, we're just going to find the common denominator of 64 in this case. So how do we get 4 to become 64? Well, we'd have to multiply it by 16, right? That means we need to multiply the 5 by the same 16, and 5 times 16 is actually 80. And then this already has a 64, so it'll become plus 9 on top. Okay, from there, we're going to end up having the statement that y plus 3/8 quantity squared is equal to 89/64. From here, we'll apply the square root property. So we'll take the square root of the left-hand side and the right-hand side. So y plus 3/8 squared will be square rooted. And that'll be equal to plus or minus the square root of 89/64. So that's going to cancel out, end up giving us y plus 3/8 is equal to plus or minus the square root of 89 over the square root of 64. I'm splitting it up like that because we can take the square root of 64, but we cannot take the square root of 89 and get a perfect root. So let's continue then with our solution. And we will say that y plus 3/8 is equal to plus or minus the square root of 89/8. All right, now what I'm going to do here for this problem is simply to move the 3/8 to the other side, and we'll end up having y is equal to negative 3/8 plus or minus the square root of 89/8. And then that can be rewritten as negative 3 plus or minus the square root of 89 all over 8. Now we'd like to see if we could simplify that radical, the square root of 89, if there's any way we could rewrite that. Well, is there anything that we can do to make 89 simpler? Well, the answer is I don't think so. I don't think we're going to be able to simplify 89 any further. There's a little trick that you should know about. If you want to decide if something has a factor in it that you're not seeing, one thing you can do is check all the factors up to the square root of the number. So if you take the square root of 89, you get something a little more than 9, right? Because the square root of 81 is 9. So the square root of 89 is something a little more than 9. That means we only need to check the things that go up to 9 to see if they'll go into 89. If they don't, then we aren't going to find any factors other than that. And of course, if you check the factors that we care about here, because we want to find something that's a perfect square to take out of the square root, those factors would be something like the number 4, because 4 is a perfect square. And then the next one is 9. That's the next perfect square. But neither 4 nor 9 go into 89. So there's no way to simplify this any further. We just have to leave it as -3 plus or minus the square root of 89 over 8. So that's our solution.